Hey everyone. Okay, so now that you've seen lots of stuff about the shapes of these graphs, let's use that. It's 100% okay to use technology to help you get these graphs, but you should take a minute for every single one of these and try and have a picture in your head of which of the three shapes you're going to see. So there's that like powers bigger than one shape. There's the powers between 0 and 1 shape. If your power equals 1, just to mention this, you get a straight line. And then the last one of these main power function shapes is the powers that are negative powers. I'll give you this sort of reciprocal shape. Okay, so it's kind of like the x squared type shape, the root shape, and the reciprocal shape. So we're going to see some of the functions that we saw before. We're just going to tack on to it. So we saw these in our algebra section. We have the magnetic field function, which is 1217d to the negative 1.98. And we're supposed to figure out what the graph looks like. So again, use technology. It's beautiful. I'm going to use Desmos, but you should already have an idea in your head that it's going to be one of these types of shapes. This is a negative power, so you should see the asymptotic behavior. So I'm just going to get started a little bit here. We have variables defined for us, so let's use them. So D, and that's units or meters, and then magnetic field, magnetic field being a little dyslexic, and its units were microteslas. Okay, so let's go ahead and play around in Desmos and see if we can get this. There's some skill involved in that too. That's not just a freebie. You got to be able to set windows and stuff. So let's get rid of the last stuff. 1217. You can use function notation in Desmos, but at least last time I checked, they're always updating. You do still need to use x as your independent variable, your horizontal axis variable. Okay, to the negative 1.98. Okay, so there's my function, and I don't see a darn thing, and I'm not surprised. Oh, I found it already. I'm not terribly surprised because I have that big old 1217. If you remember back, we actually plugged some numbers into this before. So you might have to do a little bit of plugging around and doing calculations to even figure out where it is. I happen to catch a little bit of it just by sliding my screen over. You can just click and drag, or if you have a touch screen, you can just touch and drag your graph around. But remember, you can always do just a little calculation in here. So if that hadn't worked out, we could say, okay, well, let's like plug in 5 and just figure out where the heck this is. In fact, I'm cheating a little bit. Oops, negative 1.98. I'm struggling just a little bit as well as cheating. I guess I should say that a lot of times what I would start with is 0, but I am looking at this and saying, well, that's not going to work because then since a negative means reciprocal, you'd have a 0 in the denominator. So plugging in a 1 or a 5 or whatever. And I can see it goes through 550. So even if I hadn't caught this little corner here, that would give me an idea that I definitely need to mess with my vertical stuff. So let's say y-axis goes up to, I don't know, maybe like 100, maybe even more than that. And we can kind of decide, hold on, let me think about the context once more. Sometimes you can give yourself hints here. Okay, so we're doing meters and I don't know anything about microteslas or magnetic fields, so I'm not going to get it from that, but I can kind of wrap my head around meters. We probably want to see more than 18 meters. So let's go out like 100 meters. That starts to get really flat. So maybe I don't want to go quite as high on the y-axis to make that look a little less flat. So maybe we'll do, I don't know, 60. I feel like that's not terribly unreasonable. Okay, so that's a decent sketch. And then we're just going to want to kind of reproduce this on our worksheet. So it doesn't have to be absolutely perfect, but we should absolutely show that there's a vertical asymptote. So there's that dashed line I talked about, and that's at x equals 0. And there's a horizontal asymptote at y equals 0, and I'm drawing it a little off just so you can see it, but start to get in the habit because I'll pick on you about it more when we start doing transformations of things like this later in the quarter. So we do have a vertical and a horizontal asymptote, And then our graph is going like this, getting really, really flat. And this was going up to about 60. So 10, 20, 30, 40, 50. So always label your scale. That's what those numbers are. Also label with variables or words what's represented. And this went all the way out to 100. My picture's kind of scrunched now, but let's say this is, what if this is 50? So we'll say this is 20, 40, 60, 80. So it doesn't have to be perfect, but you should label a little. And then I would say it doesn't hurt to maybe try and snag a point or two, just something, although I'm guessing in most of your problems you'll have questions that'll do that. Here, you can just, so what I did there is I just clicked on the graph and then I'm just dragging the point around. Let's see, 10 maybe? Will it give me exactly 9, 10? 10, 12.744. I'll care about this more later, but for this one I'm just going to label 1 point, 10, 12.744. I would say maybe a couple points, except the asymptotes give you a pretty good idea of where stuff's at as well.